This question is about some gas mixtures at equilibrium. The reaction can be used to make hydrogen. A mixture of 2 moles of water or steam and 2 moles of carbon monoxide is allowed to reach equilibrium at a constant temperature in a 20 decimeter cube container. At equilibrium, there are 0.92 moles of hydrogen. Calculate the mole fraction of hydrogen in the equilibrium mixture. So the method I like to use, some people refer to as ICE, I call RICE. And what I like to do is say what the ratio is, which in this case is 1 to 1 to 1 to 1. What are the initial amounts? 2 moles of this and 2 moles of this, no products at the start. And what's the equilibrium amount we've been given? We've been given 0.92. To find the mole fraction, we actually need to find the total number of moles at equilibrium. So this change is plus 0.92, and the change in the ratio line need to be in the same proportion. So everything was a 1, so everything is a 0.92. Reactants go down, products go up. So we're going to do 2 minus 0.92, which is 1.08. And then what we're going to do is total the number of moles here. So 1.08 add 1.08, add 0.92, add 0.92, becomes 4 moles in total. And so the mole fraction of hydrogen is 0.92 divided by 4. And that is 0.23. State why the equilibrium constant Kp for this reaction has no units. So we need to go back to the equation. So this would be our Kp expression. It would be the pressure of hydrogen times the pressure of carbon dioxide divided by the pressure of steam times by the pressure of carbon monoxide. So we can see that the moles of products, the number of products we have, is equal to the moles of reactants. So the units of pressure, or partial pressure if we're going to be exact, will cancel out. The temperature of the equilibrium mixture formed in 4.1 is increased. So let's just go back. Forward reaction was XO. So forward reaction is XO. If the temperature is increased, we're going to shift left in the endothermic direction. How does the amount of H2, which was a product, change when the new position of equilibrium is reached? Now, if we've shifted left in the endothermic direction, the products will decrease. Ethanol can be made from ethene and steam, and table 2 shows the mole fractions of each of the gases in an equilibrium mixture at 6,000 kPa. Okay, so over the page we're being asked to give an expression. So remember, it's the partial pressure of the products, and our product was ethanol, and there was 1 ethanol, divided by the partial pressure of the reactants, and we had ethene and steam. So make sure you don't use square brackets. It needs to be P for pressure and a rounded bracket. Now, these are partial pressures, and what we've got is mole fractions. You find partial pressures by multiplying mole fractions by total pressure. So we've got to times each one of these numbers by 6,000 kilopascals when we put it into our expression. So calculate Kp. So we've got the amount that they said for ethanol, which was 0.0321. I'm going to times that by 6,000. The amount that was for ether, 0.645, times by 6,000. And the amount for steam, 0.323, times 6,000. Using your calculator and the fraction button on your calculator, just type all that in. So on the bottom line, and your calculator should be showing you an answer of 2.568 times 10 to the minus 5. And it says give the units. And so our units, we've got a kilopascals on the top and kilopascals twice on the bottom. So our units would be kilopascals to the minus 1. State the effect, if any, of an increase in the volume. If you increase the volume, you decrease the pressure on the value of Kp. Well, the only thing that can affect a constant in chemistry is temperature, so it doesn't really matter which way equilibrium shifts, it has no effect on the value of Kp.